In order to talk about these now a little bit more easily, we're going to define what we call upper and lower values for the game. Given a choice of mixed strategy Q by player 2, we already just determined that player 1 can achieve this amount, which is the maximum over all mixed strategies P of P transpose AQ as an expected return. Player 2 would know if player 2 is determined to play mixed strategy Q, player 2 would know that player 1 can achieve this amount. That would be the biggest player 1 can achieve. Player 2 would know that, and player 2 would want to keep that as small as possible. So which strategy should player 2 announce, if player 2 is going to announce any strategy at all? Player 2 should announce the strategy Q that makes this best possible response for player 1 as small as possible, makes the expected return for that best possible response as small as possible. And that leads us to this definition. We say the upper value of the game is just the minimum over all the strategies Q and Y star that player 2 might use of this best response outcome for player 1, which of course we can also write as the minimum for Q and Y star of the maximum for P and X star of P transpose AQ. So this is just the value of the game if 1 plays P and 2 plays Q. Player 2 would like to, if player 2 is going to announce a strategy ahead of time, minimize the maximum value of this quantity P transpose AQ. We call this player 2's minimax strategy. The strategy of saying, I'm going to play a strategy Q from Y star that minimizes the maximum gain player 1 can force by playing his own player 1's best response strategy to my choice Q. And looking at things again from the opposite perspective, if player 1 announces, I'm playing strategy P, the mixed strategy P and X star in advance, I say this is what I'm going to do if I'm player 1. Player 2 can force an outcome no worse than this for player 2. In other words, we'll choose the column which gives the smallest possible return, the best for player 2. That will be this. This will be the best response strategy. And player 1 will want to pick a strategy P, which makes this best response return for player 2 as large as possible, because player 2 wants that to be large. So player 2 will want to maximize, and so choose P and X star so as to maximize this quantity that we were just talking about. In other words, maximize the minimum value of P transpose AQ. We call this the lower value of the game. And player 1 can pick a strategy P and X star, which forces the return to be at least this lower value of the game, V with a lower bar. And this is called player 1's minimax strategy. You'll see, of course, when we say it's a minimax strategy, it's the maximum of the mins for player 1, the min of the max for player 2, but they're both referred to as minimax strategies. So the upper value of the game, player 2's minimax, is what is achieved with player 2's minimax strategy, is something player 2 can say, I'll do no worse than this. That's some expected return, and on player 2, I can force the expected return to be no higher than V upper bar, the upper value of the game. V lower bar is what player 1's minimax strategy achieves, and player 1 can always force at least this return, V bar. How? By just announcing in advance the choice of P and X star that maximizes this quantity. And so player 1 can force the return to be at least V bar. Well, if player 1 can force the return to be at least V lower bar, and player 2 can force the return to be no bigger than V upper bar, we must have the situation where V lower bar is less than or equal to V upper bar. Why? Because it would be a contradiction if V lower bar were bigger than V upper bar. Player 1 would be able to force a return of at least this, and player 2 would be able to force a return no more than this, And that would be nonsense. You can't have a number that's at least this big and no more than this big if this first one is bigger than the second one. So that's impossible. That forces the lower value of the game to be less than or equal to the upper value of the game, which kind of justifies one being called the lower value of the game and the other being called the upper value of the game. Going back to the very beginning of what we talked about in chapter 4, I'm sorry, not chapter 4, in part 2, the stuff about two-player zero-sum games, we have the minimax theorem, which says not only is v bar less than or equal to v lower bar less than or equal to v upper bar, but in fact, for a finite game, the two are exactly equal. This number v lower bar will be exactly the same as the number v upper bar. And what does that mean? That justifies our calling these v the value of the game, and the particular strategies, mixed strategies P and Q that player 1 plays and player 2 plays, that achieve for player 1 no worse than V, which is the same as V lower bar, and for player 2 no worse than V upper bar, meaning a number less than or equal to V upper bar, which again is the same as V. Those strategies are now exactly what we mean by optimal strategies. Now, this is the minimax theorem. It's not obvious from anything we've done yet that V lower bar has to be equal to V upper bar. We're going to be talking over the coming week about why that's true and how we can find these things that are called optimal strategies. And remember, this is in the most general situation. We're not making any assumptions, extraneous assumptions about the game, as we have done in the previous chapters.